For the last 12,000 years, humans have multiplied and spread across the entire globe, claiming land and building sprawling megacities filled with noise and concrete. We built complex industries and burned fossil fuels to power them. In the process, we have pushed significant volumes of carbon dioxide into the atmosphere, rapidly raising the planet's temperature. But if you travel roughly 100 hours across planes, ferries, and a Russian research vessel to the Antarctic Circle, that noise entirely disappears. You are met with endless white, 24 hours of summer daylight, and absolute silence. Standing there, author Tishani Doshi was struck by a single unsettling realization. Against this scale of ice and time, the presence of human life feels remarkably brief and almost strangely out of place. It is easy to look at this emptiness and see only a cold, barren desert. Yet hidden within its layers of ice is an undisturbed record of the Earth's climate going back 500,000 years. This makes Antarctica the only place on the planet where you can observe the Earth's past, its present, and its future simultaneously. If we want to grasp the actual scale of our modern climate crisis, we cannot rely on present-day observations alone. We have to use this frozen laboratory to look backward. 650 million years ago, a giant supercontinent known as Gondwana thrived near present-day Antarctica. Over 500 million years, tectonic plates pulled that landmass apart. The fragments drifted into modern continents, leaving Antarctica isolated at the freezing bottom of the world. When you place all of human civilization against that geological timeline, our 12,000 years register as a microscopic fraction of a second. This concept of deep time makes a sobering point. The fragile ecological balance of our planet required hundreds of millions of years to form, and we have unsettled it in the blink of an eye. Today, the consequences of our rapid expansion are literally rewriting the landscape of that ancient continent. The warming driven by human activity thousands of miles away is tearing away at the ice. The symptoms are highly visible and physical. We are watching vast glaciers retreating and entire ice shelves collapsing into the ocean. To document this shift, an educator named Jeff Green founded Students on Ice, a program that brings groups of high schoolers directly to the polar regions. Green purposely chooses young students over aging politicians or celebrities. Teenagers are at an age where their understanding of the world is still forming, meaning these experiences can shape a lifetime of policy decisions. You can easily close a textbook or ignore a warning about climate change. But when you stand on a ship and watch ice shelves break apart in front of you, the crisis becomes real, and the responsibility to fix it becomes impossible to ignore. During one of these expeditions, the group walked onto the frozen surface of the Southern Ocean. They stood on just a meter of solid ice, separated from hundreds of meters of living, breathing salt water below them. Floating in that dark water is the most vital organism in the ecosystem, phytoplankton. These microscopic, single-celled marine plants are the grasses of the sea. Using sunlight, phytoplankton form the base of the food chain. They act as a carbon sink, regulating the climate. But increased ultraviolet radiation from a weakened ozone layer damages them. If they fail, the food chain starves, and the ocean's carbon absorption breaks down. The future of this entire continent rests on a single point. The survival of the largest ocean systems and the global climate relies entirely on an organism too small for the human eye to see. Recognizing how easily this system could collapse has forced nations to cooperate. Agreements like the Antarctic Treaty and the Madrid Protocol have legally shielded the continent, banning all mining and military activity. Today, that protection is actively maintained by national research stations and marine protected areas, where scientists patiently map ice loss and track ocean currents to keep the ecosystem secure. The journey ends where it began, with the idea that the health of our planet depends on our attention to the smallest details. Take care of the small things, and the big things will fall into place. Just as tiny phytoplankton sustain the entire ocean, it is our patient efforts in science, education, and diplomacy that protect our shared future.